Alright, welcome to Set of Numbers, Introduction to Sets. We'll look at definitions, symbols used in sets, distributive properties, associative property, proving sets, De Morgan's proving, and also just verifying some sets. So even symbols, we'll talk about symbols that are involved in that. So pay attention and the master what is supposed to be mastered, because it's the issue of mastering. If you don't master, then you'll be in limbo, you'll be in trouble. All right, so let's get started. So the first thing that we need to ask ourselves is, what is a set? So what is a set? So now we'll say a set it can be just a collection of things. Those things should be distinct, should be different, but they should be in a group. So is a collection of distinct elements. Yeah, let's say elements, or just objects. Alright, so that's the definition for sets. So now, since in this topic we are saying set now is a collection of element that should be different, so we'll see what does that mean. So the first thing that we are going to do in this topic, we'll be dealing with small letters for elements. So elements will be getting small letters. Then what else? Then big letters. Big letters will be for sets. Right? So a set will be presented. Let's say this is set B. We write capital letter B. If it's element now, you write small letters, right? So that means that if I say X is a member of B, so B is a set, then X is an element. So meaning this should be small letters. Do not write like X. I'm saying X is a element of B like that. No. So we'll be using small letters to mean elements, right? So that is it. So if I give you to say if I say X is element of B, meaning that X will be the element of B. Let's say X can be B can be represented by X like that. Okay, but if I say X is not element of B, meaning X is not found in B. All right, so like we said, a set is a collection of distinct elements. Elements should be different. So if I give you to say list A has the element 2, B, 6, or 2 like that, right? Then you should just list C. So to write a proper A should be A like this, 2, then B, 6 like that. So they should be different. In short, that's the meaning of distinct. Don't bring the same thing on board. No, it will be something different. All right, so they should be different. Do not repeat the same thing. All right, let's say now we are taught to describe set. Let's say let me give you set A as 2, 3, 4, 5 like that, or 6. Yeah, 6 like that. So then we are told now to say A is want to list the element of A such that is contain a list of natural numbers, and those natural numbers such that the natural number, I mean n, is a member of natural number, right? Yeah, that's capital letter N. All right, and the same N, or let me do this. We just want to see a different way of how these questions will be asked, but not really like that, but how they can be asked. Then we are saying, let's say 1, we are trying to describe this one. We say N is such that N is the number of what? I'll say A. Okay, so A is such that N is a member of who? Oh, I'm sorry. So this is A again. So I'm saying A is such that A is such that A is a member of natural numbers and, okay, so let me write it like this so that you present it well. Want to present this one, so it's a way whereby we are writing the thing. Let's say I'll say A is equal to, open bracket, like the set, just this curly bracket of sets. Then I'll say, let's say X such that X is a member of A, and, okay, and X is a member of natural numbers, okay, such that 1 is less than that X, okay, is less than that X. Again, the same X should be less than 7, like that. So you have described that set. All right, so that's how you can describe a set like that. You have described the set. Okay, you have described it. So sometimes you can be given a formula to say, let's say, let me create a formula to say, you are given to say, let's say set B is such that it has element K, which is a member of B, right? And such that the same K obey the equation to say the expression 3 n plus 1, and where n is equal to 0, 1, 2, 3, like that. All right, so manje, meaning we are going to be listing wherever there is K. So say K is equal to, we are listing all the elements, all the members that will be produced from this expression. So we'll put 0 there, then we have 0 plus 0 times that, that's 1, comma, when you put 1 there, that will be what? 3 times 1, 3, plus 1, 4. Then when you put 2 there, that will be 6, 6 plus 1, 7. I'm sorry, this is a curly brackets, I'm supposed to write like this. Then when you put 3 right there, it's 9, then plus that, that's 10. So these are the element of B, because K will be the element of B. So that's how you write. Alright, that's how you can present a set when it is given like that. So we have still a lot of things to talk about. Let's talk about terms now used. So we'll say terms used. All right, so the first thing that we are going to talk about is the subset. So a subset will be presented by this symbol, like a wrong C, just that's a subset. Okay, so if I say A is a subset of B, okay, what do I mean? I mean all the members in A are found in B. Okay, so it's like B is now the mother, where the C is looking, that's now the bigger set. Okay, meaning that the A is found in B. All right, so that is it. So the other thing that we'll talk about is the equal set. When do we say a set is equal? Like with this bracket. So an equal set, if I say A is equal to B, I mean all the things found, let's say the things found in A, elements found in A should be equal to elements found in B. They should have, let's say they should be in numbers like that, they should be also in numbers like that, then they are equal. But if there is A B like that, then here there is A, then 2 like that. Then these sets are not equal, they are just equivalent, whereby they have, they say, the same number of elements, 1 2 and also 1 2 there, but different characteristics. So those sets will not be equal, but these sets are equal. Despite the arrangement, these sets will be equal. All right, so we'll be using a certain condition to prove that. That is, if they are equal, then A should be a subset of B, and the same B should be the subset of A. Okay, so that condition will satisfy the sets to say they are what? They are equal with that condition. All right, they will be equal with that condition. So you can be lighting, Then the other thing that we can do is we'll talk about the empty set itself. So what is an empty set? All right, so an empty set, which is also called a null set, so will be presented by the symbol Q with that, like that, or sometimes we can just write it like that. It's an empty set. All right, so in this set, no element is found. No element is found. All right, so no element will be found in this set. Then the other thing that we can talk of is the meaning it has, what's this empty set, it has the properties of other sets. In short, it is outside all other sets that we have. So it's the what's this, it is the outside set, or the set that is not required. Yeah, so it has that property whereby outside the complement of this, then it has the properties of other sets. So if I say, let's say, A complement, we'll find empty set, let's say. So the properties of this, it will give us the what's this, the empty set. So that's about the empty set. So master the symbol. So after mastering the symbol, what are we going to do? Okay, let's talk about now the other thing, universal set. So universal set will be presented by the letter E or the letter U, depends, you choose which one you want. So this is a set that contains all the elements, even all the sets. So all the elements and the sets. Okay, so if I have a box like that, then I have set A and set B. So the universal is everything. Let's say there's 2 1 3 3. So all the elements found in inside this box is the universal set. So you list all the elements. So that is the universal set. Okay, right. So that is an empty set, I mean the universal set. So let's look at these properties. If I say A like that, B, this symbol, this means that it's A minus B. Okay, so meaning that if I have 2 6 4 8 in A, all right, then in B I have 2 6 4. All right, so finding this to say find A B like that, this symbol, this should be equal to A minus B. This one is the one subtracting. It's more like subtracting. So you say you remove these things from this. So you remove from this, you remove 2 4 and 6, so you remain with 8. So that's the answer. All right, so that's this symbol take note of it. This symbol, take note of it, is same as this one. It's more like you are subtracting. We'll get to prove a lot of things using the same symbol. All right, we'll get to prove a lot of things in future questions to come. All right, so we'll be using that symbol to prove questions in future questions to come. So what if we have now another property? We'll say A complement. It can also be described as removing universal minus A. Okay, so meaning that if we have set A like that inside the universal, so inside the universal, what we are going to do is to find A complement. Let's say there's 2 here, there's 6. All right, so to find A complement we know is 2. So we'll just do this. We'll just go there in the universal and subtract 6. So the universal is 2 and 6. That's universal. Now we are going to subtract A. So meaning that our A is 6. So and we had the 6, 2 in the universal. Now we are subtracting what? 6. What are you going to remain with? We are going to remain with what? 2. So meaning that A complement is same as A complement, we know that is 2, is same as this expression here. So A complement, it can be expressed as universal minus A. So this property. So if I give it to say universal minus n set, let's say B, you should just write B complement like that. So that's the thing, so master these. Hope you are writing them down. I'll be writing because I only have one body. I'll be writing. I only have one. You'll be pausing the video for you to get what is needed. All right. The other thing that we are going to do is let's talk about this now. If I say A is a subset of B, meaning that there are elements found in A, they are found in B, and B should have even the extra. So if I say A is not a subset of B like that, meaning element in A are not found in B. All right, so that is it. So I've talked about two equal sets whereby you follow the condition to say you need to prove something. So we have talked about empty set as well. So example, let's do this. Let's verify one thing. Let's say we have set A is equal to 1, 2, 3, 4, 5, 6. All right, 7, 8, 9. No, let me just end on 8 like that. So this is set A. Then set B we have 3, 6, 9, 12 like that. So comma 15 like that, 15. All right, then set C as well we have 2, 5, 7 like that. So now we are told to say find A intersection B. So we go where A and B intersect. In short, what are the similar things common in A and B? So we have 3 there. 3 is found in this one, and also it's here, and also it's there. So meaning you have 3 as the first thing. Then what other thing? I can only see 6 being found here. The rest are not common. So 6. So that's the answer you can give. So when you're asked A intersection B, you look at things that are intersecting, in short, which are equal or same, then you'll be able to find that. But what if you are asked to say find B union C like that? So for us to find B and union, you get everything in B and in C, but you don't repeat the listing thing. So in this case, the list here we can have is 2, as you can see, 2. Then there's 3 as the odd number from above 2. Then the other number is 5. We are listing everything. 7, 12 and 15, like that. So that's the set we are listing now. That's the set we have listed. So what if again we are asked to say B intersection C? So we want to talk about things that are common in B and C. So I can only see, what number can I see there? I can't see any number, so I'll say that is an empty set. Or you can say, you can just list it like that, then you are done. Okay, very simple. So that is it. Let me use another page. So properties. No, this page is not nice. We'll go back. So properties now. So I'll be fast because of time, and also you'll be pausing the video and you also see what we are talking about. I know it's very difficult when I'm labbing very fast like this, but just make sure that you pause the video. Then after I'm done, after the page is full, then you look at things on the board, then you write somewhere there. It will be of help. So the other thing that we can talk of is the properties. Now we'll talk about properties of a set. So say properties so we'll look at different properties. Please pay attention. CBU student, pay attention now. Pay attention. So the first property that we are going to look is when I give you a complement like that, and again complement that outside like that. So if I give you like that, so this means that it's A. We multiply this complement times complement to give you positive. That's just a matter of mastering things. We'll get to prove and also verifying if possible, so if time allows. So what we are going to do is you multiply this complement times this complement, you get A like that. So that's a property number 1. So if you see this, it's same as this one. Okay, so if you see this is same as this one, from now get to master that. We master things here at the university, so that's how we do things. Master to say a complement outside complement. It's more like this complement multiplies. Are you getting me? Sure. So that is it. Then the other thing that we are going to talk about is if I give you to say A union, allow me to say, all right, so if I give you to say A union A, it's more like I'm adding everything in A, and we said a set is a distinct, this property. So meaning you don't list the same thing, I mean you don't repeat, so you just list the same A. Have you seen? So that's property number 1. It's more like something in A. We have 2, 6 like that in set A. Aye. Then I say to say, can you A union A? It's more like you are adding the same A, but we don't add the same thing. We only write an element once, we don't repeat. Get that clear? So meaning that A union A still give us A. Then what if we have A intersection A? What would be our answer? So we are intersecting A in A. It's more like we are just again adding the same thing on top of, let's say, a slice of bread. Again you put the same bread, it is still the same slice of bread. We don't repeat. We would have said 2 slices of bread, but it's still the same bread. So say it's still A. Okay, but this property of which we have already talked about, if I say A like that, that's the minus we are from talking about, which is just the I've just given you like this to say A minus B, like that. Meaning that, can you have something in B? In this case, I'm just giving you find the set like this. So meaning you don't have any things in common. If it was B, you would have written 0, something like that, or empty. So now this thing, they won't have something in common as they are right now. So what you do is you say this is an empty set, because you won't get anything. These sets are not the same. It's more like I have set A. Set A, it has, let's say 2, 6, 6, like that. Then set B, it has B and A. Are you going to get to subtract anything? No, the answer is no. So when you find them like this naturally without any given sets, then you say that will be your empty set. All right, so that's your empty set. The other properties, hope these things are clear. Just get to master and also analyze them in your head, then that will be okay for you. All right, so the other thing that we are going to talk of is what we call commutative, associative, distributive. So we'll start with the commutative. What do we mean when you say commutative? What's the meaning of commutative? So for commutative, if you are given to say A union B, this should be equal to B union A. It's just the arrangement which matters. If I give you again to say A intersection B, this is same as B intersection A. That's the commutative thing. All right, so if you have 2 times, let's say A is 2, then B is 3, like that. Then also this side we have the same thing here. So if we multiply this time that, it will give us 6. Even if we write 3 times 2, we'll still get 6, like that. So that's what it means. So these things are just equal. All right, so that's the meaning. Then the other thing that we can talk of is the associative. So associative, we just associate things. Associative. So for associative, we associate thing. So let's say so these are properties, by the way. So if I tell you to say A union B, like that, then C. So these are properties, you find them as you are starting then. So don't get confused, just master and you'll be okay there. It will be very simple when you come, especially you haven't come into the university and you are trying to start, by all means. So this thing is more like, now we are trying to associate the brackets. We are not changing anything, we are just trying to associate the bracket. We'll get these brackets here and try to put in the next level. So say A union B union C. So the brackets were at first, now we'll move one step, so we'll leave the other set, so we'll put them here. So that's what we call associative. So we have associated the the properties. So what if again we have A intersection B, like that, B all right, so B intersection C, like that. Then how do you associate the property? The property can also be associated again like this. We can bring them here. So say A intersection B intersection C. So we associate these properties. I'll bring them here. That's associative. All right, that's associative. So the B will be getting into all the scenarios. So that is it. So the other thing that we can talk of, the other property, allow me to lab here. The other property that we can talk of is the let's talk of distributive law. or property. So for distributive, let's say we have A intersection B union C, like that. All right, then we are distributing this A intersection inside, and this will be our separation. Okay, so it's more like it's just a matter of algebra. So I'll say 2b is equals to 2b is equal to 2b is equal to 6 minus 3a, like that. All right, so if I multiply this will still remain the separation. So this and this will be attached. That will be what? That will be 12b. Then this and this, that will be what? Minus c 6c ba, right? Or ab. So this will still remain. It was on the middle, so this thing will still remain as the separation. Get that? So I'm saying this union will still remain like this negative we have seen here. All right. So that's what we are going to do. We'll say all right, we'll say a intersection will go with b. So we'll say a intersection b, like that. Then this u will still remain as the separation, just like you saw that negative. Then again, the same A intersection will multiply times C. So we are distributing A intersection there. That's the game. Alright, so this is the property. We'll be able to prove these things. We will be able to prove. So just master to say, oh, this is a property. Not really important, but just master to say, when we are saying this, we have just distributed. So you can say what type of property was used. It's distributive law. For this one, it was associative law. For this one, it was associative. This one was commutative, of which just the same. For associative, we just associate the brackets. For this one, we just distribute. So you master things like that. It will be very simple for you. All right. So that's about distributive. Then the other case in distributive, we can say, let's say we are given A union, open bracket, A union, open bracket, like that, B intersection C, like that. So if we distribute it to be A union, so it will be A union B, like that. Okay, A union B, like that. Then what this will still remain as the intersection, like that. Okay, then open bracket again, A union, it will go with C, A union with C, like that. So that's the meaning here. So that's how you'll be proving these things. So I forgot one thing on the properties, those properties at first. So that is it. Hope you have copied all these things. All right, I'm too fast because of time. I don't want, when you download the video and you use a lot of band, just light this. You pause the video and light it somewhere. So that's how we master things. All right. So the other thing, if I tell you to say universal set complement, this should be outside. It's more like outside the universal. There's nothing outside it, so it will be an empty set. Even if I say again that empty set, all right, that empty set complement, it will give you an universal, because outside universal is empty, and empty complement, then you go back in the universal. All right, so universal or presented by you whatsoever. So that's the thing. So master also this property. All right, master it. So if I tell you to say can you let's say I have this property. So if you see A intersection B, like that, complement, you can also write it. You distribute this complement. The moment you distribute it, so it will be, allow me, So the moment you distribute this complement, this once it crosses what is on the mid, this what is on the mid changes to union or intersection. So if I distribute this complement, so it will be A complement. Have you seen? The moment it has crossed this common thing will change to U. Then this also multiply there, it's B complement, like that. So these are the properties we're about to start now. So just master like that, okay? So the other case that we already talked about is a situation whereby I have this A like that, then I open bracket, let's say B intersection C. So it's more like A minus open bracket B intersection what? Intersection C. That's the thing here. So meaning that if I'm multiplying this thing here, so if we are distributing this thing and under distributive, so you are saying this thing will change. So if you are distributing that thing, so want to distribute A into all these sets, so it will be A this comma minus B. All right, so even light the bracket like that. Then this thing, the moment this crosses this comma negative, in short the complement is a negative, so the moment you enter inside, then it changes, like just it has changed here, it has affected this union the moment it crosses. So this is also a negative we are talking about, of which it will be changing things. So here once you distribute this negative here, so here it will be union. Have you seen? Then open bracket again, the same negative, this negative, you come there, so it will be A like that C. So that is the thing. So that's the thing. That's how the negative will be moving. It will be changing what is on the middle. Are we good there? Are we good? So now finally let's talk about proving sets, and that's what De Morgan's. Under De Morgan's there are 3 properties that will be required to prove. So the other one is arbitrary method. Alright, so for De Morgan now, De Morgan's proving, so this is where now it is getting to be interesting. So De Morgan theory. So for De Morgan theory, there will be properties. There are 2 of them. So the other one, let's talk about it. The other one is the first one is the one we just said, to say if you have something like that, so if this distribute inside, that will give you A. It will be more like negative times negative positive. All right, so now prove. So for us to prove, we'll be moving with the condition. Prove that A complement outside brackets complement like that is equals to A. So for you to prove, there is light and left side. So light and left side. So what you are going to do is we'll say we need to show. So this is how we start to prove. We need to show that this is the condition that you should start whenever you're proving a set, not verifying but proving. So you say A complement, like open bracket like that, should be the subset of A, and okay, the same A should be the subsets or the subset of A complement like that complement. All right, so that's how it will be moving like this. It will be moving like this. So now we can start from right hand side. So let's start from left hand side like that. So the other symbol that you need to know is if I say let this opposite A is the word O, like O. Okay, so that's a word. So I'll be using that let O. All right, so so O is equal to this letter I. O, that's the word O. So let O excess be a member of, we are proving from right hand side, left hand side. All right, so let all members, let all X members let all x's be a member of what? Be a member of a complement like that, complement like that. Meaning that it's a game now. Please, De Morgan, it's a game. It's a game. So if you don't get the game, then you lose. So we are saying x now, meaning that x or x's is a member. Is not a member. We'll say it's not a member because we want to remove one thing. So it's not a member of a complement like that. Okay, even you just removing the bracket, this thing is just the same as it's not a member of a brackets like that. I've just removed the brackets, so it's nothing I've changed. So meaning that x is still not a member because I've changed like a complement. At first it was a member when complement was there, but this time around it's not a member because complement out, the other complement has been removed. Then the same thing where I've just removed the brackets here. Don't get confused, you can jump this step. So meaning that x now will be a member of a because I've removed again. So this will be just changing the element thing, will be just changing the element thing. So I will even say to say therefore I'm done here. X is a member of a. I've proved. So I'll say a complement like that. I've found what is a subset of a. So that's case number 1. All right. So that is from left, starting from left. Now starting from right hand side. All right. Starting from right hand side. So I'll say allow me to use this word, let all x's be a member of a. Have you seen the game? So all x's are a member of a now. All right, we are starting from this so since we are starting from there, then we are saying x will not be a member of what? A complement. Why? So again, x will be a member of let me say x is still not a member of a complement like that because it at first it was given as a member of just a. So meaning that x now will be a member of a complement like that, like that. Have you seen the game? So the game is now almost done. So meaning that you say therefore you are done now here. So the issue is what you target. So you are targeting the other side. So and you have finally reached this side. So I'll say a complement like that. No, just a. A is a subset of what you have found, which is a complement, open bracket, complement like that. So that is a. So after doing that, you say from right hand side and left hand side, comma, you can say a complement like that. The question now is equal to a. You have verified because you have shown that the subset of this one is a subset of the other set. So meaning that those things will be equal because every distinct elements are found in both sets. So those sets will be equal. Okay. All right. Okay. So that is it. So the other thing that we are going to talk about is now proving the other so that is it about this one. So don't get confused. All right. So hope you have copied this and also try to attempt different questions. So that's about De Morgan's. So that's De Morgan 1. There must be 3 and we'll prove all of them. That's where now it is getting interesting. So make sure that you understand this video. It will help you, especially you CBU students. It's for you and others just universities. All right. So let's get to De Morgan 2. So this is now case 2. So for case 2, we'll be given to say B is a intersection C like that, complement, this should be equal to, we'll prove, but by the way we said when this one multiplies inside there it will be B complement, then this will change to C complement like that. So this is just a law of De Morgan, so we'll prove this one as well. So this one, it is just like that. They'll bring in an exam to say, can you prove the De Morgan? So this is the thing, we know that we can multiply by multiplying, but that's not proving. So we want to prove now, that's just simplifying, but we want to prove now. By us proving, we'll state the condition again to say we need to show that we need to show that so that is the B intersection C complement, open bracket complement, that is a subset of what? B complement union C complement. And the same thing here, we'll say we'll say C complement union B complement is a subset of what? B intersection C like that complement. So in short, we should show the condition. We need to prove this condition of just stated here. So now we'll say from left hand side. Okay, so from left hand side, so let O x's, let O, you can even use this one with this letter. Let me just use the same one. Let O, alright, let O, no, let me just use the same my letter. I like this one. So let O is just slipping opposite A. So let O x's be a member of what is on the left. So say it to be a member of B intersection C open bracket complement like that. So that's the thing. So meaning that X now, alright, since we are saying this now, say X now is not a member of, we remove that. So say B intersection C like that. I've removed the brackets, which was these brackets I've removed. So meaning that X is not a member of, I'm just distributing this for every member, so it's not a member of B. Then for intersection we use, so intersection we use and unless it changes. Then for union you use O. So now there's N there, so I'll say and, then again X is not a member of the same C. So meaning that X will be a member of B complement. Then the moment you are changing everything, it has changed the element thing, then here you put O, you change as well. That's the game. So then you write X is a member of C complement like that. So meaning that we have reduced the work. So we'll say X is a member of, so we are saying now X is a member, by the way it was intersection, now it is now a union. So say X is a member of B complement union C complement, and that's what really it's there. So we'll say therefore, because you have reached the target there, you target something, you target the other side when you start solving. That's how you will not forget this thing. So say it was B intersection C open bracket like that complement is now a subset of what you have found here. So it will be B complement union C complement like that. Alright, so we have proved the other way, the other side. So I'll also say you write now down after proving. Now my board is just very small, then you write also down there So I'll also prove from right hand side. All right, so meaning that I'll say let all x's, by the way, we can use even that letter I told you for word or, let all x's be a member of B complement union C complement, like that, meaning that x, all right, meaning that x is a member of B complement, or x is a member of C complement. So now things changes here. You target something before you even proceed, how you are going to be moving all these steps. You target, you know your target is to reach here. So now what you're going to do is you say x now is not a member of, you have changed something, is not a member of B. Have you seen? Have you seen there? Okay, we are changing now. We are moving from this side. We want to target that side. All right. So x is now not a member of what? X is not a member of. Let me lab. The thing here is when you have this one, when you have x, you have started this equation to say want to prove it, right? Want to prove it. So what you do is you have just said these are just, you have changed nothing at this stage. You have changed nothing, right? Yeah. So manje, what you do is it was the intersection, right? It was the intersection, it was the union. So now I want to take it into intersection, then we'll be ready to go. All right, we'll be ready to go. So what we do is we are saying x now all right, so x now, our target is to reach this point here. So how are we going to achieve that? All right, so it was O, so now I'll say x is a member of x is not a member of B, and x is not a member of C, like that. So meaning that x is not a member of B, right? Then intersection C, they are all not a member. I'll put the bracket. I have the target, that's why I'm writing this bracket. So now x will be a member of B intersection C. All right, intersection C, then brackets, because Z at this point, it was, when it was not the intersection, it had no brackets there, but here it is now the member. So meaning it need to come with something. That's the negative, the brackets were, I mean the complement we're able to see here. So from, by the way, this word, so I'll say I'll use that one. So allow me to lab this. Before I even lab, let me see if I can have a space. Okay, so meaning that from right and left, we can now so we say that's the conclusion now. From left hand side and the left, that's right and left hand side, we can now say that B intersection C complement is equal to B complement union C. So hence proved. Hence proved, like that. So you write hence proved. That I'm just run out of space, I would have done it for you. So that is it. Allow me to lab. that's how you go about these things. So you can light them somewhere. Yeah, I'm very fast because of I don't have space, and if I go back you'll be confused. I mean, I go to the next page, you forget this thing, so I'll just be on this page. All right. The other thing that we can talk of is we have proved there are so many De Morgans, and don't forget the conditions that I've just given you. So the other thing that we can prove is now case 3. All right. So for case 3 now we'll say B intersection. Remember the other one, it is just the same thing, by the way. It's just the same thing. Just the same thing. Even if I give you like this, C open bracket complement is equal to B complement union union C, like that. So this is the same thing that we are from doing. So it's a complement here. So it's the same game we are from playing. So you can just try this game and inbox your answer in because I just wrote it the opposite, the other way around. So now again you need to show the other way around, or we can do it, let's do it together. So the same, you make a statement. We need to show that what is on the right side should be the subset of what is on the right side. I mean, what is on the left side, and also the opposite, the other way around. So say B complement union C complement, and the same B complement union C complement should be the subset of B intersection C open bracket complement, like that. So that's the statement we need to make. So let's start from the left hand side, like that. So from the left hand side you say let all x's be a member of open bracket B intersection C, like that, complement. All right. So meaning that x now is not a member of, I want to remove this bracket with this complement, which is not a member of B intersection C. All right. So this means that x is not a member of B. This thing is the oneness when you change this condition, that's when this. So for now it is called and x is not a member of C. I've changed nothing here. So meaning that x is a member of what? B complement. Then this one again changes because when you bring something you always change even the word. So that is now A O from and now to O. So union and intersection, this is union. Then this is x is now a member of again C complement. All right. So meaning that I can just bring them together. I'll say x now is a member of B complement union C complement, like that. Have you seen? We have reached here our target. So that's the thing we do here. So therefore you say therefore B intersection C complement, like that, is a subset of what? Is a subset of B, what you have just found, C, like that, complement. All right. So that is it. So that's how you'll be proving the other condition. So that's proving 1. So now proving 2, we are starting from right hand side. So right hand side you say let O x be a member of B complement union C complement that. All right, meaning that X is a member of B complement, or O is U. X is a member of C complement again. So now we want to change things here. All right, so we'll say X X is not a member of B. All right, and X is not a member of C. All right, that's the meaning there. So we'll say X is not a member of B and is the intersection now that we have just brought in the game. So see, like that, they are not them. So meaning that X will be now a member if we put the bracket like that. So intersection C open bracket brackets like that. So meaning that therefore B union C complement like that is equal to, or is a subset of, B intersection what you have just found C open bracket complement. So that's the thing. Then therefore from left, you say from left hand side and left hand side like that, we say now these sets are equal. So you say what it was on the left side, which is B intersection C like that complement, is equal to B complement union C complement. So hence proved. So we have proved the De Morgan. So that's how we deal with De Morgans. All right, so you guys, I'm fast. I don't know if I'm fast, but you can still be pausing the video. All right, so now that's case 4 now that I want to give you. I want to give you case 4. So that's how it goes. You prove it to say hence proved. So it's just a game. So if you don't master the way the game changes, then you face challenge. There's nothing to understand here, it's just to master. You can't understand this because they are just letters and you don't know where letters came from. So I don't see the reason of you struggling to understand. You just master to say, oh, things should be mastered in school. That's when they get to process themselves in the head. So they should be mastered. We all master things. Not those who understand are the one who wrote them. So that's the thing. Then case 3, case 4 for De Morgan. So now we'll be now verifying or showing. All right, so given the sets, let's say I give you 2 sets, then we'll prove one De Morgan. We'll say, okay, let's show that A union B like that complement is equal to A. We proved this one as like it was the first one to prove B like that. All right, so this is the thing here, and we have been given, let's say universal set is equal to 1 2 3 4 5 6 7 8 9 10 like that. All right, then I have set A as well, set A as well as the 1 2 3 4 5. So I'll say 1 2 3 4 5 like that. So that's set A. Then set B, I'll say set B 2 3 5 7 like that. So want to prove, want to show or verify. So what we are going to do, be moving like this. So A union B like that, then A complement intersection B like that, complement. By the way, I said when this complement goes inside, then it changes the sign and everything like that. Here it was union, now it has come as intersection there. So that's now we want to prove. So you master them like that to say when distribute take a complement, the complement, then it will be coming like this. All right. So now what we are going to do, be moving now step by step. So list A union B and D complement. So what is not found in A union B, we'll be moving whether we'll get the equal thing. So this is from the left hand side, this is from the right hand side. So we'll be proving which one are we going to get the same thing. So let's bring A union B. So A union B will have, in A we have 1 2 3 4, we just add them. So we'll say 1 2 3 4 5, right, in A. Then in B we have 2 3 4 5. In short, there is no 6 among these two. From the universal we add this, then we subtract from the universal, then that's the complement. So things are not that are not found in A and B, that's a complement. So we are adding them, then those not which are not found outside what is inside, that's what we want. So A union B will be 1 2 3 4 is found in A, 5 is found in A again also 2 is found in B, 3 is found in A, in B as well. So then the only thing 6 is not there, so like it will list even 7 like that, right? So here for A complement and B, so we'll say we'll list A complement. A complement is those things that are not found in A, and we have 1 2 3 4 5, meaning we have 6 7 8 9 10, those that are in A. Then intersection, those that are in that are not found in B. So for things A, you remember it was 1 2 3 until 5. So those that are not found in A, that was 6 8 7 like that until 10. But for B now, so this was for A complement. So for B complement now, we'll be moving using this equal sign. If we'll see whether they will be equal like that. You move like that. Then we are saying now B complement you have 2 3 4 5 6, meaning that those things that are not found in B, things that are not found in B will be what? 1 is not found in B, the other thing is 4 is not found in B, 6 is not found in B, 8 is not found in B, and 9 including 10 is not found in B. Okay, so we are intersecting these. So for this one, remember this was the complement. All right, so A union B complement is this. So now for this one, we want to see now things that are not found in this one. So we are listing now the element. Remember this was just A union B like that. So now we want to list the complement, things that are not here. So we have 6 is not there, 8 is not there, 9 is not there, and 10 is not there. So for this one, which one they are intersecting now? We are intersecting. So which one are common? So say 6 is found in both sides. We have what else? 8 is found in both sides. We have 9 in both sides, and 10 like that. So we have shown that hence shown. So you say hence shown that, hence shown, in short, hence shown A union B like that complement is equal to A complement intersection B complement like that. So we have shown that this is equal to this. So that's how you show sets. So master the word showing and also proving. For proving, it was where you say let all x is something like that. That's the thing. So you can pause the video and copy this. because we only have one board. You pause the video, you write, you look at thing. After I'm done explaining solving the question, then you look at thing, you look at the board, then you see whether you have understood or preview the video. So that is the thing. Then the other thing that we can talk of is let's say we are taught to say, let's see how the complement will be moving, will be changing things. So if I give you to say A intersection, let's say B union B complement that. So when you distribute, they say I light even like that, I light like that. Have you seen? So I light even a complement outside, like so. You respect the bracket, so this bracket will multiply there. Have you seen? This will be positive. Have you seen? So it will be, then it will start from, you start from the left. So once this multiplies there, this complement, so it will be complement. So since it has jumped this n, so you now write union. All right, then open bracket B union. All right, okay, B union B like that. Allow me to write like this. Then this complement and complement, this one, because they were in the bracket, so you multiply just once and they'll give you positive. So that's what you say now, A complement union open bracket B union B. So this will give you just a positive, of which they cancel in short. Then now you distribute now this one. Okay, in short, you have simplified the, let's not compromise things. We can use distributive rule, but forget about it. So that's how the complement will be affecting these things. So we are told to say, can you show that, let's say you are told to say, can you show that A intersection B, using distributive, associative and the commutative property, show that A intersection B like that, union open bracket A intersection B. It's more like you're using factorization to do these things. So we are told to show that this one is equals to this. So what we do is you multiply this times in short, you factorize. You can't multiply because there is something separating, a big difference. So you factorize. What is common between here? It's A intersection. So A intersection there, you remain with B. Then this one doesn't change, you remain U. Then A intersection there, you remain with the B complement like that. All right. So when you have B union B complement, you are bringing things to say, you are bringing B and its what, and its complement outside. So it's more like you have a set B there, set B there, there's universal there, there's 2 there, and there's 3 there. Then we are saying now, can you bring B and B complement? B complement is 2. Then and can you bring again B, so which is 3. So obviously this is just universal. You are bringing these things again. We are told to say, can you find B complement, of which it is now 2. B complement outside B. Then again unite it with the it's with just its complement, I mean with just B. You are bringing again the same 3, so it will give you again the universal thing. So you can write E or U like that, universal. So meaning that A intersection universal. So A intersection universal like that. So now what you are going to do is you are intersecting to say, let's say you have a set like that, set A like that, then universal is there, then let's say set A has 2. Then now we are telling you to say, can you intersect A and universal? Universal doesn't have anything, then you are intersecting. They will intersect where A lies. More like you are putting your a pen on your book. Where do a pen intersect with your book? It's where pen is, so the answer is A. So you put A like that, and hence what? Shown. So for showing, you just do one side, hence shown in such a case. Hence shown, because you are told to say show that this one is equals to this, and hence shown. So that's how we master these things. That's how we do. So the next thing, we'll do a tutorial sheet, and in that tutorial sheet we'll be looking at different questions, of which some things are not talked about, but the other topic is set of now. It will be set of numbers, integers, if they are proving to say irrational, expressed in the form of A over B. So watch out and watch the video. So be updated. Tactical Academy got you. Alpha, your 7. So that is it. You can inbox me whenever you want a tutorial sheet after this topic. So the number is 09700200920, Tactical Academy. So you find us. That is it. Thank you very much for watching the video, and please share the video, subscribe, comment, so that we can improve on the way of delivering the information to you. We love you. Thank you. Stay blessed as we. So for those who are home, you can now start preparing. Those in school, you can also do the same thing. You will even see that, oh, this is where I need to concentrate when you start training. But for now, master everything. They'll help you. You have a lot of information. You'll not be stuck at some point, because we have covered everything needed here. So your duty is just to master. Write a book, get a book, and also master everything needed. Thank you very much. We love you, and don't forget to subscribe like we said.